All right, and this will finish up chapter 1 for us. This isn't too crazy of stuff here. All right, it's just going to be some more specifics about um, the unit circle and those types of things. The first thing, we have the domain and range of sine and cosine functions because they're kind of an oddball for us. Uh, those two are going to be the ones that have a domain of negative infinity to positive infinity, or all real numbers. Okay. Now this is just sine and cosine. Tangent is, it doesn't fall under these. But the range for these are always going to be -1 to 1. Okay. Now, reason being is you have something that's called um, what's repeating functions. Okay. So you can have something that's bigger than 1 because of that, but up and down on your graph, it's never going to go higher than that. But it can go farther out the x-axis, essentially. Okay, so that's what that means. All right, so then even and odd functions. So cosine and secant are the oddballs here for even and odd. Cosine and secant are going to be your two even functions. So even if you want a cosine of a negative angle, you can basically ignore the negative sign and just find the cosine of that positive angle. Okay? The rest of them are going to be odd. So if it's an odd function, okay, if it's an odd function and you have the sine of an angle, say you have the sine of pi over 4, what you can do is take that negative sign, put it out front, and then just find the positive angle. Okay, so all these are ways you can rewrite these to make it easier on yourself. All right, so let's use these here. Look at first one, the cosine of -45 degrees. So is cosine an even or odd? An even. So basically that negative sign means what to us? Nothing. Okay, it means nothing. So I'm just going to rewrite this guy as the cosine of 45 degrees. Now, yes, this is in degrees. Most of the time we were using our radian measures. But looking at this thing, cosine of 45, I look at my unit circle. What's the cosine of 45? What is it? Root 2 over 2, correct. All right, so that's my x value at 45 degrees. So all I did was use the fact that it was an even function to rewrite it and go from 45. All right, make sense? Now, let's look at this real quick on the unit circle. All right, now 45 degrees is right here, correct? If I went -45 degrees, all that means is I start here at my origin, and usually we go this way. That means I went this way 45 degrees, correct? Well, going down 45 degrees, going the opposite direction, is going to put me at what value? 315. What's the cosine of 315? Root 2 over 2. So instead of having to stop and think, all right, I'm going to go the opposite direction, all right, then I have to subtract from 360, we just reuse the even and odd properties. That's what these are for. Does that make sense? They're time savers. That's all they are, time savers. All right, so let's get back down here. All right, next one. I have the tangent of negative root 3, or negative pi over 3, not root 3. Negative pi over 3. All right, so is tangent even or odd? It's an odd function. So basically, take this, rewrite it as the tangent of pi over 3. What is the tangent of pi over 3 using your unit circle? It's pi over 3. What is it? Root 3 over 2. Well, tangent is y over x, right? Give me both of them. What is it? Over 1/2. Okay. Now we still have a negative out front, right? We have the negative from here. All right. Cancel the 2's. So I'm left with negative root 3. Correct. All right. Next one. I'm going to erase this so it doesn't fall into the next guy here. Next one, we have the cosine of negative 60. All right. So cosine, even or odd? Even. So my negative sign is essentially nothing, right? So this is going to be the same as the cosine of 60 degrees. Looking at unit circle, what's the cosine of 60 degrees going to be? What do you got? Half. Correct. Correct. All right. Then we go tangent. Tangent of negative pi over 6. Tangent, same as in number 2. It's an odd function. All right, so it's an odd function, so you pull it out front. It's negative tangent of pi over 6. So what's that going to turn into for us? Negative root 3 over 2? Over 3. Agree on that one? Okay. Question so far. All right, I'm going to give you 2 here. I want you to give me the sine of, let's go, 3 pi over, negative 3 pi over 4. And I want the cosine of negative 4/3 pi. All right, take a minute and try those 2. All right, who didn't do a question the first time? You didn't do a first question the first time? All right, you got the first one. Sine, even or odd? Odd. All right, so this is a negative out front. So that turns into 3 pi over 4, correct? So then it's going to be what? Root 2 over 2? It'd be a negative, correct. So it'd be a negative out front. All right, who wants the last one? Since you can't count, you got this one. All right. Cosine, even or odd? Even. So that means our negative sign's irrelevant, right? Okay. So now we're looking at the cosine of 4 pi over 3. Cosine of 4 pi over 3 is negative root 3 over 2. I agree. Everyone else agree? I agree as well. All right. This thing's pretty handy to have around, isn't it? Makes our life a lot easier on us for this unit circle. What's that? Yep, you're right. Sorry.
I told you, I get mixed up with mine.
Yep, good call. You're correct. All right. All right. All right, questions. All right. So a couple other things just to to kind of talk about here quick. A periodic function, this is a repeater function. All right, that means as you go, it's going to go around in circles over and over again. It's going to repeat. It's kind of, remember back in like lesson one, we standardized angles. So an angle might have been 900, but we just kept subtracting 360 to get it between something from 0 to 360. That's pretty much what this is. So a periodic function, roughly your sine function, if you graph it out, which we're going to do in the next chapter, it kind of goes like this. So it's the same function repeated over and over and over again. All right. So a function is periodic if there exists a positive number p such that t plus p equals f of t. For all t in the domain of f, the smallest positive number p for which f is periodic is called the period. So we'll see more of that in the next chapter. The period is how long it takes for it to make one full revolution. Okay. So basically from here to here would be one period. Okay. All right. That's just kind of, I'm just giving you a kind of a flash into the future here. All right. So then the periodic properties of sine and cosine functions, they're based off of 2 pi. So basically, if you want the function of something, you can rewrite it as, you can take the 2 pi away. So if you have 3 pi, for instance, it says the sine of 3 pi. The sine of 3 pi is the same as the sine of pi because it was pi plus 2 pi. All right. So this is what this means, and we'll use this right here. All right. So sine and cosine, they're both exactly the same. It's whatever that extra is, and they're periodic functions with a period of 2 pi. So for this one, cosine of 420 degrees. Well, 2 pi is the same as how many degrees? 360. So basically, I can rewrite this guy as the cosine of, what's 420 minus 360? Why is that funny? 60 to 60 plus 360, right? All right, so now I'm only worried about the cosine of 60. 420, what we started with. Okay, so look at your unit circle. What's cosine of 60? 1/2. Correct, 1/2. Okay, second one, sine of 9 pi over 4. Well, 9 pi is bigger than 2 pi, correct? Because 8 pi over 4 would be 2 pi. So I can rewrite this as the sine of pi over 4 plus 2 pi. Agreed? All right, so after I rewrote it, then I can essentially take that 2 pi out. So now I'm just looking for the sine of pi over 4. What's the sine of pi over 4? Root 2 over 2, correct. Still with me? Okay, last two is you. Okay, cosine of 405 is the same as what? Cosine of 45, correct. Okay, because 360 minus, 405 minus 360 is going to be 45 degrees. What's cosine of 45 degrees? Root 2 over 2. Okay, it's root 2 over 2. Now the sine of 7 pi over 3. That's the same as what? It's the same as the sine of pi over 3. All right, so then that's going to be, correct, root 3 over 2. Questions? Easy? That's what we like to hear. Usually, unit circle, everybody loses their mind.